Hey guys, janky old way that we're gonna do the study guide again. Sorry, but it does the trick, so it's all that matters. Okay, so we're gonna continue on with number 12. Oh, there's 12. So I give you that indicator. Use your special right triangles or unit circle to find the exact value of each expression without using a calculator. On all of these, I am going to solve using my reference angles. I am not going to solve using the unit circle. If you are planning on using the unit circle, that's all you. That's memorization, and so really, there's no extra work that you have to put here that I'm going to put in. Like I said in class, your work is going to be essentially attaching your unit circle that you've created on that day of the test, during the test, not before, not, anytime before, whatever. So that's that. Okay, so we're going to start off with just looking at each angle measure. I think I'm sitting in like the squeakiest desk ever. I'm sure you guys know that feeling, but every movement I make it squeaks. Cool. Okay, so we have 3 pi over 4. So first thing is figuring out what my reference angle is. Well, my reference angle, I feel like I should learn to abbreviate. My reference angle, well, my denominator is 4. And remember, anytime the denominator is 4, my reference angle is going to be 45 degrees. And then, okay, so that helps us with figuring out what type of triangle we're going to draw. But then what we really need to know is to figure out what the sign of tangent is going to be, we need to know what quadrant it's in. So 3 pi over 4. There's a lot of different ways you can do this. One way you can do this is converting it to degrees, and then, you can just look at your coordinates and, okay, so 0, 90, 180, 270, and 360, and go from there. What I do is I essentially have the radians memorized of where they are. We talked about it in class. So I look at this, and so 3 is 1 less than 4, so that means it's in quadrant 2. So this would be quadrant 2. Another thing that you can actually do, if you would prefer, is you can get you can look at the radians of each of these. So instead of writing 0, 90, like 180, you could write 0, pi over 2, pi, 3 pi over 2, and then 2 pi. And what you could do for all of these, because we're looking at pi over 4, you could get these all into over 4 and then compare where it would be. So this would be 2 pi over 4. This would be 4 pi over 4. And so hopefully you recognize, okay, 3 pi over 4 is in between 2 pi over 4 and 4 pi over 4. So it's in quadrant 2. And in quadrant 2, tangent is negative. Okay, so at that point, I'm just going to draw my triangle. And I'm using a 45, 45, 90. So I have 1, 1, and rad 2. And so I'm looking at angle. So I have my opposite, my adjacent, and my hypotenuse. And tangent is opposite over adjacent. Remember, it's negative, so I'm just going to put negative 1. Okay, and then minus 7, sine of 7 pi over 6. So we're going to do the same thing for 7 pi over 6. 7 pi over 6, my reference angle. There's my abbreviations at its finest. It's over 6, which means my reference angle is 30 degrees. Now, I know that, okay, it's 1 more than 6. 7 is 1 more than 6, so that tells me it's going to be in quadrant 3. But if you wanted to do the same thing over here, you could. You could also convert it to degrees, or you could, change these all to be, okay, let's see. So pi over 2 would be 3 pi over 6. This would be, 6 pi over 6. This would be, we're multiplying it by 3, so 9 pi over 6. And then hopefully you can recognize that 7 pi over 6 is going to be between these two. And so it's in quadrant 3. And so in quadrant 3, sine is negative. So I would draw my triangle. I'm drawing a 30, 60, 90 with the focus being on my 30 degrees. So across from the 30, it's the smallest is 1. Across from the 60 is my next smallest or middle sized is 3. Rad 3, sorry, and the hypotenuse is 2. And so I'm looking at 30. I have my opposite, adjacent, and hypotenuse. And so sine is opposite over hypotenuse. It's a negative, so we'll be subtracting a negative 1/2. So a negative, or a minus a negative becomes a positive. So negative 1 plus 1/2 becomes negative 1/2. And that's my final answer for that one. Okay. So we're going to move on to 13. 13 gives me 2 cosine of pi over 3. Now pi over 3, hopefully you guys know pi over 3 is already, like, we don't need to find a reference angle for that. Pi over 3 is the same as 60 degrees. So we just can, like, that's in quadrant 1. So we don't really have to worry about anything. And so we can just draw our triangle right off the bat. Okay, so we're looking at our 60 degree, 1, rad 3, 2. And so we have we're looking at 60, we have our opposite, adjacent, and hypotenuse. And cosine is my adjacent over my hypotenuse. So we're doing 2 times 1 over 2, so 1/2, plus, okay, now I have to do the same thing for 7 pi over 4. Look, unfortunately, that one's not as easy as this guy was. So 7 pi over 4, my denominator is 4, so the reference angle I know is going to be 45 degrees. Now 7 pi over 4, this one's kind of funny, but like with 2 pi is 8 pi over 4. It's 1 less than 8 pi, so it's going to be in quadrant 4. And then in quadrant 4, sine is negative. Now, if you were like, what? How did you figure out it's in quadrant 4? You know, you can kind of do what I've been doing up what I did in 12. You can essentially write them all over 4. So pi over 2 would be 2 pi over 4. Pi would be 4 pi over 4. 3 pi over 2 would be, 6 pi over 4, and 2 pi would be 8 pi over 4. So then you can recognize that 7 pi is in between here, so it's in quadrant 4. And then we draw a triangle. So 45, 45, 1, 1, rad 2. And so sine, I guess we have our opposite, our hypotenuse. So 1 over rad 2, we need to rationalize the denominator. Yikes. So that would be rad 2 over 2. So at this point there's, oh, and sine is negative. Yikes. So don't forget that. So one thing I want to say here is there's 2 ways that you can write the answer to this. You can write it as 1 minus rad 2 over 2, which is fine, because this would simplify to be 1. Or we can get them to have the common denominator and write it as 1 fraction, which I did. So when I multiply the 2, remember it only multiplies to the top. So it would be 2 over 2 minus, because a plus, a negative becomes minus, rad 2 over 2. They have the same denominator already, so I can just write it as 1. 2 minus rad 2 over 2. And that's my answer for 13. Okay, so let's keep going with 14. 14, we have 4 sine of 10 pi over 3 minus 4 cosine of 7 pi over 2. So with this one, for both of these actually, we need to first, before we do anything, we need to find their coterminal angles. The reason we have to do that first is because 10 pi over 3 and 7 pi over 2 they're both greater than 2 pi. So we need to find their coterminal angles. Okay, so for 10 pi over 3, I'm going to subtract 2 pi. Now, you know, I can subtract 2 pi, but I want to get a common denominator. So if I want to get it over 3, that would be 6 pi over 3, which gets me 4 pi over 3, which is in our unit circle. And then I'm going to do the same thing for 7 pi over 2. Now 7 pi over 2, I'm again going to subtract 2 pi, so which would be, want to get a common denominator, so 4 pi over 2. And we get 3 pi over 2. Okay, so at this point we have our coterminal angles that are within the 360, so we're going to use those. And then we're going to, you know, do the same thing that we did before. My reference angle for this, it's over 3. My denominator is 3, so that means my reference angle is 60 degrees. 4 pi over 3, so 4 is 1 more than 3, so it's in quadrant 3. And we're looking for sine, and sine in quadrant 3 is negative. Okay, I'm going to draw my triangle, the 30, 60, 90. We're focusing on 60. And so I have 1, rod 3, and 2. So 60, I need my opposite on my hypotenuse. So I have 4 times rod 3 over 2 minus 4 times whatever we get here for cosine. Now, 3 pi over 2 is one of our kind of like special ones. It's our 90 degree one. Or not our 90 degree, but well, one of our like 90 degrees. And 3 pi over 2, excuse me, is the same as 270, which if we're looking at our quadrant is down here. And so that is left and right none, but down 1, so our point would be 0, negative 1. So remember, my x value is my cosine. My y value is my sine. C comes before s, x comes before y. Okay, so we're looking for the cosine, so it would be 0. And so 4 times 0 is just 0. Yay. And then we can simplify, we can simplify over here. So the 4 and the 2 can, like I would simplify those first to become 2 and 1. And so then I just have 2 rad 3 minus 0. And I did what I didn't want you guys to do, and I forgot to put that negative. So sue me. So it's, I mean, honestly, like, I do it too. It's obviously like, I'm doing it fast. It's the easiest place to make mistake is your signs. So I do really want you guys to like take these slow. Obviously, I'm not. I'm, you know, going through them fast because I'm watching my computer slowly die on me, which is fun. But you need to make sure that you are not, you know, focused on your computer dying, but you're focused on your signs. So make sure you do that. That's why we do this. If it helps you, like, you can always draw your triangles in the correct quadrant, which might help you with your signs then. And so my final answer, negative 2 rad 3 minus 0, is negative 2 rad 3. Okay, so my computer's at 13%. Do we think I can keep going? I'm going to go with a no here because 15 looks like it's a little bit of a longer problem. So we're going to have to pause here. I'll finish the rest of these tomorrow once I've charged my computer. Sorry I didn't get these all to you guys tonight, but I'll finish them tomorrow. Sorry about that. And bye! I kind of like having like physical hand in there. I would put my face in, but no one wants to see that. So, see you later.